Hey everyone, this is our project for VGG-based NO2 estimator using satellite images. So having precise air quality predictions is very essential in understanding how emissions and harmful substances affect our society. Currently, this study is only being done in very larger or metropolitan regions with very limited availability of understanding of NO2 levels in smaller or localized areas. So our primary function of this project is to create a CNN model that would predict the NO2 levels very precisely for smaller regions as well. And our model would primarily be focused on identifying NO2 parameters between the ranges of under 15 to 58 parts per million. And this scale is split into 15 different classes as well. So initially for this model, there was absolutely no training data set available which directly had the NO2 features mapped to a particular satellite region. So we created this data set ourselves using the input values provided by the London Air Exchange website, which provides a NO2 map in this format. This is very specific to London region itself, but this region also is split into various topographical regions like densely populated or into regions like densely forested regions which have a very low NO2 value, higher to moderately populated areas which might have NO2 values in this greener region, and densely populated metropolitan regions which have a very high NO2 level. Based on this, we have created our input image dataset, which has the NO2 values mapped to the accurate satellite image. This satellite image has been obtained from the Sentinel V2 satellite imaging source from NASA. Now, since this is very specific to London, we wanted to create a model that would cater to all regions in other places as well. So since this kind of topography is found in other regions as well, we wanted to split this into a larger data set so that training our model would be easier. So to begin with, we have split our input images, which are based on different regions in the London topographical area, into each image so that it maps into 100 different images. So this particular one sat image was split into 100 different images, and so was this corresponding NO2 map. And so running this function will give us 100 images or 100 input NO2 patches that we can pass or use to train our data. So this also increases our data set as well as makes our model more sensitive to the smaller features that it can catch from each of these patches data. So this patch would include the smaller split of the region. But with this, there also comes a problem that the NO2 patches may not be of equal sizes. So we have also used padding so that the blacker region of the image is eliminated, and we are only left with the accurate data that we need. Like this. This would not have any padding or any region, which we can avoid. Moving further, once this is passed accurately, we do get our NO2 patches in this format. Post this, each NO2 map, as we saw here. Now, if we zoom in, this might have a lot of NO2 values, right? And we want an average value that can be mapped to that particular satellite image. So to do this, we have taken each pixel out of this image, and we have generated a map that generates the average pixel value for the NO2. For example, this blue parameter might represent 15 NO2, 15 ppm for NO2. This orange might represent 52 ppm for NO2. So when you calculate the average of it, it might fall under like 30 or 40 ppm for NO2. So when we run this program for calculating the average NO2 values, we do get a training map of this form. So we have the corresponding satellite image, the corresponding NO2 patch, and the average NO2 value that corresponds to these areas. So post-processing this, we are also removing the NO2 values that might be 0. This can be an outlier because our NO2 value should lie between the ranges of 15 to 58. Anything that is extremely out of the box from these values is considered as an outlier, and it may affect the sensitivity of our model as well. So we are removing the 0 value NO2 completely from our model. And when you pass this model, we finally get our training data final, which is of this form. So we have removed all the 0 values as well from this. And this is the data that we will be passing through our model. And we have chosen VGG because VGG is also a pre-trained regression model, and it has been trained amongst thousands of images. So when we tested it against random forest or other CNN models, VGG was one of the best ones that gave us the best accuracy of approximately 87.6% for passing a mere 14 to 20 epochs. We have chosen 20 here because we have chosen 20 epochs here because 20 was giving the apt accuracy without diminishing further. But also similar accuracy was found beginning from the epoch 14 as well. So once we pass our model this code, we have chosen Adam optimizer, which works best for our model. And for the loss function, we have chosen mean square error loss function. And once we run this code, the training data is evaluated, and we do get our VGG NO2 regressor path that we can pass for further testing. And once this is complete, we did pass a new image, and this image was used for testing, which I'll be showing shortly. And once this is complete, we do have the final NO2 value that is predicted for this function. And to visualize this that we saw initially in the beginning, we have used Gradio to settle for the OS user interface that is much more easier to understand and represent the value as well. So we are using this very generated model path that has the state file saved in it. And once we pass through it, it generates a link for us to load. And this is the very link that I was showing in the beginning. So when we pass our input image in this form, I would like to show that again. So we are taking a random input image. This is not an input image from London at all, by the way. This is from India. And once we load this image, it would be displayed in this form. And once we click predict NO2, and we will get our final NO2 value. This value was validated against the London air mapping as well to check if this would fall under the same region. And since this is an image from India, we verified this value against the ground values provided from a website called Bhunidhi, and this was aptly captured as expected. So yeah, that's our model. Thank you very much.